Now next article is if phi is equal to AJK, AJAK show that phi is equal to BJK, AJ and AK, where BJK is symmetric tensor. So this tensor will be converted in this form where this BJK is a symmetric tensor. Now this let phi equal to this values. Now this can also be written as phi is equal to AKJ, AK, AJ. So just replace K and J. Adding these two equations, so we get 2 phi equal to AJK plus AKJ, AJ into AK. Now this implies phi is equal to these values. This term should be equal to BJK. So substitute this tensor is equal to BJK. We know that this BJK is a symmetric tensor. So it means phi is also converted in this form. So that is our result. Now next is very important topic. So this is a metric tensor, fundamental tensors. We know that in rectangular Cartesian coordinate, the distance between two neighboring points whose coordinates are xyz and x plus dx plus y plus dy and z plus dz. This is given by ds square, dx square plus dy square plus dz square. So that is in equation number 1. If we put this x as x1, y as x2, z as x3. So this equation can be written as in this form g11 dx1 whole square g22 dx2 whole square plus g3 dx3 whole square. So this term can be written in this form gij dxi dxj, that is by Einstein's summation notation. Now this idea is extended by Riemann to n-dimensional space. So it was up to 3 coordinate. Now Riemann extended this idea to n space. It means I is running from 1 to n and j is running from 1 to n. Now distance between two adjacent points, this is a, so this will become ds square, which is equal to summation I summation j into g ij dxi dxj. So this can be written in the form of gij dxi and dxj, where gij is the coefficient which are function of xi such that determinant of gij, which is a non-zero. So determinant of gij which is equal to non-zero. So next topic, Riemannian metric. So the quadratic differential equation, which is of the form of gij dxi dxj, which express the distance between two neighboring points, is called Riemannian metric or line element. Also it is called metric simple or it is called line elements for n-dimensional space, and it is denoted by Vn. The quantities Gij are the components of covariant tensor of rank 2. It is also named as metric or fundamental tensors. The geometry based on Riemannian space is called a Riemannian geometry. Now, conjugate or reciprocal tensor. Let determinant of GPQ is non-zero. It is denoted by G. and define a GPQ. So this is a contravariant tensor. Remember, GI Riemannian metric is a covariant tensor. So this is a contravariant tensor. This GPQ, this is defined by cofactor of GPQ in determinant GPQ and divided by G. So this is a reciprocal, reciprocal or conjugate tensor. Now, this GPQ is a contravariant, number one. Number two, symmetric tensor of rank 2, and it is called a conjugate or reciprocal tensor of GPQ. So, how we can find this term? This is a cofactor of GPQ in determinant GPQ over G. Now, the fundamental tensor Gij is a covariant symmetrical tensor of rank 2, right? So first result. Now consider the coordinate xi, which is transformed to x bar I. So in this coordinate system, the metric is Gij dxi dxj. So this is transformed to Gij bar dx bar I dx bar j. Since ds is invariant, so it is invariant in any two coordinate system. So both the equations, this equation and this equation, they are equal. If both the equation equal, then we know that dx bar I, this can be written as dx bar I curly x1 dx1 plus curly x bar I curly x2 dx2 plus so on up to nth term. This can be written in the form of summation. So this is curly x bar I curly xj dxj. So that is in equation number 2, right? If we take this dx bar as a bar and dx is a bar, simple a, so it means this is a bar I into this into a j. It means this a is contravariant vector of order 1. If it is a contravariant vector of order 1, what is a? A is a dx. So dx I, dx bar I, which is a contravariant vector of order 1. Similarly, we have dx bar I, which is equal to this values. Now shift, find the value of, and similarly dx bar j. Now putting in equation number 1. So dx bar I, dx bar j, that is in equation number 3. So substitute this value in equation number 1. This is dx bar I, dx bar j. So substitute the value of dx bar I and dx bar j, right? So we get, in that case, we get this equations. So we get this equation. On simplification, we get this equation. Now, this equations. Now change from this ij in term of pq, this values, and here it is g ij bar curly x bar I dxp curly x bar j curly x q dx dq. It implies this value equal to 0. Now this is an arbitrary tensor. If it is arbitrary tensor, then this term is equal to 0. If this term is equal to 0, then what we get? We get GPQ which is equal to Gij bar curly x bar I curly x p curly x bar j curly x q, and it implies Gij bar which is equal to Gpq curly x p by curly x bar I curly x q over curly x bar j. So it means it is a covariant tensor of rank 2. So we prove that here it is a covariant tensor of rank 2. Now second property, it is a symmetric. Now we know that we can write this tensor in this form because it cancel with this, and this total will become the Gij. So first part can be written as Aij, second part can be written as Bij. So this is a symmetric tensor, this is a skew symmetric tensor. If skew symmetric tensor will become 0, then Gij will become a symmetric tensor, right? So what is our purpose? Our claim, this Bij, yani skew symmetric part, it contribute nothing to Gij, right? So from 4, again, from this equation, we can write it as Gij dxi dxj. Substitute the value of Gij, we get these values. Now Aij taken left hand side, we get these values. Now interchanging dummy indices in Bij dxi dxj. So this will become Bji dxj dxi. So take from this term is basically the same as this term. Why? Because just interchanging a dummy indices I and j. Due to skew symmetry property, this Bji is converted into minus Bji, and it implies 2 Bij dxi dxj equal to 0. It implies Bij dxi dxij 0. Now substitute this term in this equation, equation number 5. Substitute in this equation number 5. So we get this term equal to 0. Since are these are arbitrary tensor, then this term will become 0. If this term will become 0, then Gij, which is equal to Aij, Aij is symmetric tensor. So Gij is a symmetric tensor of rank 2. So which prove the two property. Property number 1, Gij is a tensor of rank 2. Second, it is a symmetric tensor. Third is, prove that Gij, dxi, dxj, it is an invariant, right? So in order to prove it is an invariant, by definition, Gpq bar, which is equal to curly xi, curly x bar p, curly xj, curly x bar q into Gij. So this can be written in this form, which is equal to 0, right? Which is equal to 0. Now multiply by these values. This is equal to G bar curly x I curly x bar p curly x bar j curly x bar j Gij equal to 0. Now multiply by this term equal to 0. So we get G bar pq dx bar p dx bar q, which is equal to Gij curly xi dx bar p curly xj curly x bar q curly x bar q. So this cancel with this term, this cancel with this term. So we get Gij dxi dxj. So we get G pq bar dx bar p dx bar q, which is equal to Gij dx bar I dxj. It implies Gij dxi dxj. It is a invariant, which prove the result.